Okay, so we're looking at the systems unit still, and we're looking at word problems. So we're solving word problems, and we're going to use systems of equations to help us solve them. Now, often word problems will arise that will involve two equations. So there's going to be two equations, but more importantly, there's going to be two unknowns. So these must be formulated and the equations then have to be solved. Okay, so let's take a look at the first one here. Adult and student tickets were sold for a school play. Okay, that's interesting, but literally tells me nothing that I need to know. Adult tickets cost $5. Okay, that's useful. Student tickets cost $2. Nice. A total of 2,812 was collected, and a total of 1,055 people saw the play. How many adults and how many tickets were sold? Okay, so we have to think of what's unknown. We know, so we already know how much the tickets cost. For adults it's 5, for students it's 2. So those aren't unknown. We know those things. We also know how much money was collected. That was given to us. And we also know how many people attended in total. But what we don't know is how many adults there were and how many kids there were. So we're going to say X is X and Y. Those are going to be our two unknowns. So let me just write unknown. Our unknown. So X is going to be the number of adults. And then we can say kids will be the number, or sorry, Y will be the number of kids. So the number of adults that attended the play, obviously. And let Y be the number of students. Now we already know how much they paid each, but we don't know how many in total there were of each. Yeah. Now that we have these unknowns, there's going to be an X and a Y. You need to know that we need to generate two equations. We always will need to generate two equations. That is important right now. Because we have two unknowns, we need two equations. So, what can we possibly do with these equations? Well, the number of adults that attended and the number of students that attended, we actually know what the total will be. It says that there was 1,055. So that's one equation. 1,055. So we don't know how many of them were adults or how many were kids, but we know that if you added them together, you would get 1,055. We also know a little bit about the price. So we don't know how many adults there were, but we know that it cost $5. So if we times it by 5, however many adults each paid $5, plus however many students each cost 2. So every $5 times however many adults there were, $2 times by however many students there were, we would get a total of $2,812. So again, we don't know how many adults there were. That's unknown. But we know that if you times it by 5, that's how much money you'd make off the adults. And we don't know how many students there were, but we know that if you times it by 2, that's how much money you'd make off the students. And if you added all of the student money and you added all of the adult money, you'd get a total of 2,812. So we've got 5x plus 2y equals 2,812. Now that you have that, we can actually solve this because we have two equations. And we need to do exactly what we did the previous time. We need to get x and y alone. So I'm actually going to move this. I'm going to put 5x plus 2y equals 2,812 up here. And now I'm going to get y alone. So start on the left. All we have to do is minus over this x, minus over the x. here. And so we have y equals I can't combine them, so I'll just go negative x and then plus 1055. And here I will minus the 5x from this, both sides. Again, I can't add the like terms over there because there are none. I have to just keep them separate, and I'll write the x first. And then I got to divide by 2. So y equals negative 5 over 2x plus, well, half of this, half of 2800 is 1400, and half of 12 is 6. So 1406. So I have two equations, and now I can do y equals y. So I just want to see how much room I have here. Okay. So now I'm going to do y equals y. So I've got negative x plus 1055 is equal to negative 5 over 2 x plus 1406. And we can get common denominators for all of these things. So times it by 2, times it by 2, times it by 2, times it by 2. That's already 2. Times these by 2. So I've got a negative 2x over 2 plus, that would be 2,110. 55 is 110 over 2 equals negative 5 over 2x plus, and this is 2812. We already cut that in half, and now we're doubling it again. And now I am out of space, so I'm going to hit enter here and lower this. And just like we did last time, now that the denominators are all 2, I can times the numerator by 2, and that will cancel. And times this numerator by 2, and that will cancel. So I have a negative 2x plus 2,110 equals a negative 5x plus 2,812. So I'm going to move over the more negative one, which happens to be the negative 5. That's more negative, so I'll move that over by adding it. And that will give me a 3x plus the 2010 equals 2,812, which then I can subtract the 2,110 from both sides. So 3x equals, I can actually do that vertically. 2 minus 0 is 2, 1 minus 1 is 0, 8 minus 1 is 7, 2 minus 2 is 0. So 702. And then I could divide that by 3, which I don't know what that is, so maybe I'll do that over here. 3 into 702. 3 goes into 7 twice. Carry down the 0. 3 goes into 10 3 times, which would be 9. Subtract that. Carry down the 2. And 3 goes into 12 4 times. So my answer here is x is equal to 234. And what was x again? What was, is that our adults or is that our, let's take a look what I have. X is the number of adults. So there we have it. X is the number of adults. Now we need, this is all, remember this is all the same as what we've been doing. Now we need to find y. So we can pick the easier equation. So I got 2 here. Or I could use the original ones that I had. So I'm going to use not the fraction one, not the one, so not that one, and not that one. That's got too many numbers in it. So I can go for either one of these, but I always like to go with the one that's already y equals. So I'm going to do that one. So negative x plus 1055. negative x plus 1055, and we know that to be a negative, now what's x? 234 plus 1055, and now we need to just add those together, which maybe I should do off to the side here. 1055 minus 234. Now I realize it says negative 234 plus, so I just flipped it. I wrote the positive 1055 first, and then the negative down below, and I could just subtract it. So that's 1, that's 2, and that's an 8. So y equals positive 821. So we need to do some sort of, before we did a therefore statement with an x and a y, and we would tell the point. Now we're not really going to do that here because we want to answer the word problem. So therefore the number of adults is 234, and the number of students is whatever I said there, 8 something. Yeah. Therefore the number of adults, which I'll put in brackets, remember that's x, is 234. And then the number of students, which we made was y, is 8, what did I say, 821? Yeah. And there you have it. So everything about this question was identical. It's just that I never actually gave the question. I had to instead give you a paragraph that you kind of had to read, and you had to generate the 2 equations. So definitely a lot more work, and that's why there is a practice example for you to try in the worksheet. But let's try in the next video, we'll do question number 2.